Alright guys, so we're going to talk about rotations real quick because I noticed a few things looking over the exit tickets on rotations that we just don't understand. So the first thing is some of us don't get quite what the center of rotation is, right? There are three things you have to have before you can rotate something on the coordinate plane. The first one is you need a center of rotation. So this is just what you're going around, right? It's always going to be an x, y coordinate, but this is, again, it's what you're going around. What are you rotating around? All right, and this is always going to be some place on the xy coordinate plane. So I will say, rotate this around the point 3, 2. And you'll just have to put a point at 3, 2 and move your whole shape around that. Maybe I say rotate about the origin. About the origin means that your center of rotation is just 0, 0. But the center of rotation is a very important thing. You have to rotate around something if you're rotating. You don't just get to pick any place. You have to pick the place that I tell you or the question says. All right, the degree, which is how far are you rotating? All right, and as we said, we're only gonna do things in 90 degrees, 180 degrees, or 270 degrees. All right, and this is basically how many turns are you doing? And you'll see what I mean by turns in a second when you use the patty paper. This is 1 turn, 2 turns, or 3 turns. And then the direction is which way. All right, this just asks which way are you going? You can either go clockwise, which is the direction a clock usually goes, or counterclockwise. All right, so that's the gist on that. Okay. So that's the three things you need. You need to know what you're rotating around, which is always going to be a point. You need to know how far you're rotating, which is going to be a 90 degree, 180 degree, or 270 degree, or as I would think of it, 1 turn, 2 turns, or 3 turns. And you have to know which way you're going, all right? So just as a quick aside here, this is clockwise, okay? So just literally think of a clock, all right? You got 12 up here, 3, 6, 9, and then you have your hands, But the hands always go from noon to 1 to 2 to 3 to 4 to 5 to 6 to 7. So like this way right here, this is clockwise. All right, so if you're spinning this way around the circle, then that's clockwise. If you are spinning this way, same thing, we have a clock, but obviously the only way to get this clock to spin backwards is to go backwards in time, which is impossible. So clocks don't move in this direction, in this direction. So this is clockwise right here. This is what I'm talking about when I say we're gonna spin this or rotate this clockwise around this point. This is counterclockwise. All right, if we start going the other direction, so instead of going from 1 to 2 to 3, maybe I'm gonna go this way around the circle. Because again, clocks don't spin this way. Nobody will ever see a clock spin this way unless you're like setting your own watch, because this would require, in reality, time to go backwards, and that's not gonna happen. So as a result, this is clockwise, and this is counterclockwise. I'm sorry, I just said that wrong. This is clockwise. This is how clocks usually spin. This is counterclockwise. All right, know the difference. Now, I'm gonna give you an example of all three. So let's say we're gonna rotate this figure right here, and then here's our y-axis right here, just so you can see what I'm talking about. Okay, and then here is our x-axis. All right, so let's rotate this figure right here, QWER. And we're gonna rotate this, all right? I'm gonna list these things up here. Our center of rotation is going to be, let's just say -5, 2, all right? And then our, let's see, we're gonna say our degree is we're gonna rotate this 90 degrees, and we are going to rotate this clockwise. All right, and this is what the problem would say. It would say rotate QWER around the point -5 to 90 degrees clockwise, and that's all I would have to say. All right, and here's how you do that with patty paper. And this is the part where most of you guys pay attention, because I noticed that we did not get this. Most of us did not rotate our figures correctly. So first, before you put the patty paper over and trace the figure, you want to figure out where your center of rotation is, all right? And you need to highlight that place. So it's going to be 1, 2, 3, 4, 5, 1, 2, right? So there is the point, 5, 2. That is our center of rotation right there. Then you end up applying patty paper, and you have to make sure that your patty paper has the shape on it, the entire thing, and the center of rotation, right? So first you want to just trace the shape on both sides. And with rotations, you also want to label your vertices in advance, all right? So this is Q, this is R, this is E, and this is W. And you want to put that before you start with the rotation, all right? Then you want to go over to your center of rotation, okay? And you want to put not a point, but a cross, all right? And just to make this, drive this point home, make a really big cross so you guys can try and tell what I'm talking about here. So I'm gonna make that big cross right there. All right, big cross. And that is what you're gonna spin around, okay? And this is what I'm talking about when I say 1, 2, and 3 turns. So now you're gonna put your pencil right there at the center of rotation and use it as a point. So we're gonna go clockwise, all right? Clockwise is this direction, because that's how clocks move. So we're gonna spin it 1 time this direction until all my cross lines up again. And that is what I mean by 1 turn. So this is a 1 turn, this is 90 degrees. If I spun it twice and lined up again, that would be 180 degrees. 3 turns would be 270 degrees. And then this would always be 360 right here. All right, so to make this easy on myself, I'm just going to color in the back of my triangle too, or not my triangle, my shape, my quadrilateral here. I'm gonna color that in, and that way, when I spin it, all I have to really do is just line it up and then color it in again, because a little bit of it will be left behind. All right, like that. So you can barely see it, but there it is. And now I can go over it a little bit more. But that's what that is, all right? So we took it from here, we rotated it to there, and that's it. All right, now the only thing you have to do is label your vertices. So this is gonna be the point Q prime. This right here is W prime. This is E prime. And this is R prime. And this is another point that we need to learn, because I told you guys for rotations, you want to label your vertices in advance, because if you don't, you're gonna get lost, all right? So a lot of people I saw on the exit ticket, they would have the right abbreviations here, like they would put Q prime, R prime, E prime, and W prime, but they wouldn't put them in the right spot. It was like they just like, well, as long as I have my vertices somewhere, that's okay. And that's not true, all right? This vertices right here, E, for instance, all right? When you rotate this figure, it doesn't end up just anywhere. It actually ends up specifically right there. So you need to label that one with E prime, okay? And that's how rotations work. You need to first mark your center of rotation on your paper. Then you need to trace your figure and then draw your cross on the center of rotation. and then just spin it the number of times, number of degrees. So 90-degree turns are always 1 spin, okay? 180-degree turns, 2 spins. Always lining up your cross here, right? 3 turns is 270 degrees, and then this would be 360, right? Or you can go the other way. If you went counterclockwise, it'd be 1 turn this way. But you guys get the point.